kind of irrelevant to this, but if I had A plus B yields AB, right? So they were detached and then they were together, right? A and B, at this point, they're completely separate, right? At this point, it's like A connected to B, right? During the middle is what's called the transition state, where there's what's called a partial bond between A and B. So it's like forming, not completely formed, not completely not there, it's there. And that's called a partial bond. So it's like right before they connect, right? And like this superstructure, which is like right before they connect, is called the transition state. It's very unstable. It requires a lot of energy to maintain it. That's why this has the highest energy. Compared to the product, the reactants and the product of that step, transition state requires the most. Does that make sense? Yeah? So this has two transition states. Activation energy, you guys should have seen this before. The activation energy is the point from the reactant to the transition state, so the P. So that's the activation energy of step 1. All right, EA1. And then this is the activation energy of step 2, which is EA2.
Just to clarify, so I put transition state, you said that's when like the pressure bond occurs.
Yeah.
So like what is A bond like partially bonding to in that case?
So like that's why this is not a good example, because like it should like sometimes it would, like for example like you don't need to know this, but let me just apply it to 14D. For example, you have like let's say CH3, CH3, H3CI, right? Please don't write this down. This is like too complicated for 14B right now. You can if you want, but so basically, you see how this turns into this, and like technically it's plus I minus, like that went away. You got like this detached, right? Does that make sense? Like this broke off, and then now they're separated, right? The transition state will look like this. So C, CH3, 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 and then the I went from attached to detached, so it's a partial bond. It's like coming off, right? Not completely off, not completely detached, somewhere in the middle. Does that make sense? Okay, so partial bond. So basically, the difference between intermediate and the similarities between intermediate and transition states is they both don't show up in the overall reaction. Differences: intermediates have full bonds; they're full molecules. Like this is an intermediate, for example, because something next step is actually gonna react with this. Like if I give you another step, this becomes the intermediate, but it has full bonds, right? Versus a transition state has partial bonds. Does that make sense? Okay, so now let's talk about, so this is the activation energy for reaction 1. For reaction 2, if I add a catalyst, what's gonna happen? It's gonna lower, right? So if I ask it to draw it, you should be like, okay, this goes from here to here. It will say like usually it's like one step, like it won't be like two stuff like this. So let's say I said there's a catalyst that affects step 1, then you would draw like that because it only affects step 1, right? So then if he's like draw a graph of the catalyst, you have to just show it that it's lower. Does that make sense? Usually you just have a one-step stuff and he'll be like, okay, draw the catalyst. Okay? Now, if I asked you to calculate the activation energy, if I gave you numbers like 5 and 10, let's say that was joules, what's the activation energy? 5, right? Because it went from 5 to 10, so this is 5 joules. Does that make sense? Okay, so, now let's talk about the rate of the reaction, right? So each of these, so remember how we wrote the rate laws? So the rate of step 1 going from A to B, I'm gonna label as little k, right? I'm gonna say little k1, okay? Showing the rate going from A to B, right? If I show you the rate going, does that make sense? The rate constant for step 1 is little k1 in the forward direction. Now if I want to say the rate in the reverse direction is little k1, and I'm going to say prime, just to say that it's going in the reverse direction. Sometimes you see little k negative 1, same thing. Okay? Depending on who's your TA, and I know some TAs do negative 1, some people put prime. Doesn't matter, same idea. Okay? You can do negative 1 if you want. Negative 1 I feel like would be better, so we can just say negative 1. Doesn't matter again. So then I'm going to say for step 2 is little k2 in the forward direction, and it's going to be little k negative 2 in the reverse direction. Does that make sense? And then each of these steps has some equilibrium constant, big K1 and big K2, right? Like, you learned this in equilibrium, right? Every reaction has some sort of equilibrium constant. Now, one thing that, so remember, the equilibrium is when the rate of the forward direction equals the rate of the reverse direction, right? So it's a ratio between the forward and the reverse, right? Or little k1 over little k negative 1. And k2 over little k negative 2. Okay? So then, and now I told you that the faster the rate, the bigger or smaller the rate constant. If it's faster, bigger, right? So, and then how do you know if it's faster? Based on, like, you can tell by the height. Which one's easier to go over, a little hill or a mountain? A little hill, you can run over it pretty quickly, right? So, which one's faster, going from A to B or B to C? B to C, right? Which one has a higher rate constant, A to B or B to C? B to C, because it's faster, it's higher rate constant, faster, right? So maybe I ask you a question like, which one has the fastest rate in the forward direction, B to C, and A to B has the slowest, right? Which one has the fastest rate in the reverse direction? B to A, because I'm comparing C to B, which is super high, or B to A. That make sense? And then slowest rate would be C to B, right? If I tell you which one's the rate determining step, usually you assume the rate determining step is in the forward direction, right? Most of the time, but let's say rate determining step in the forward direction, right? So which one would that be? Remember, rate determining step, or RDS, is the slowest step, right? So would it be A to B or B to C? A to B. A to B, because that's the biggest mountain, right? It's like when you're cross country, you're like running, right? And then like you have one big hill, and you know there's that big hill that exists. That's going to determine the race, right? Not like the flats and everywhere else, right? All about the metaphors, right? So, okay, which one has the greatest rate constant overall, reverse and forward? A to B, B to C, or C to B, B to A? Which one of those four? B to C, right? Smallest step. Competitor is B to A, but this is still smaller. Rate determining step in the forward, I said it was A to B. Rate determining step in the reverse, let's say C to B. Usually he asks forward, but in case he asks reverse. Let's see. Okay. What's the spontaneity of this reaction? Okay. So, one thing first, before I even jump into that, this is energy, right? So if I say, which one's more stable, products or reactants? It takes less energy to handle the products, because this is the amount of energy, right? This is like the amount of energy it takes to hold that in position. So this, let's say, takes 2 joules of energy. A takes 5, right? It's like a hyper kid with a lot of energy and sugar versus a like mellowed out kid, right? Which one's harder to take care of? The hyper kid. So you want to have the mellow kid, right? So which way do you think this is going to naturally go? Towards the stable, right? So it's going to go towards the stable C, and if I want the reaction to go, what is that, spontaneous or not spontaneous? Spontaneous, because spontaneous means it wants to go that way, right? Versus if it was the other way, we would have to have a really good reason to want to get there, because if it's like this, right? I would have to have a really good reason to get here because I have this huge activation energy. This is more unstable compared to A. I'll get to that in a second. But so C is more stable, so it's going to be spontaneous. If you couldn't remember that, just make up numbers. Let's say this is 2, this is 5. Delta G tells us spontaneous, right? So final minus initial. 2 minus 5 is -3. -3 is spontaneous. Negative spontaneous, right? That makes sense? So make up numbers. You know, you have to pick any number less than 5. Or if this is 5, this is 4, 3, 2, or 1. Or you can go to decimals if you really want to. But okay, so fast. Let's go. Is K? So in this whole reaction, let's say in this whole reaction, is K greater than 1 or less than 1 or equal to 1? Greater than 1, right? Remember, the trend is that if you have delta G, if it's negative, then K is going to be greater than 1. If it's positive, K is going to be less than 1. If it's 0, then K is equal to 1. And then you can also plug in a chart for the EMF, right? Remember, this was positive, it was spontaneous, this is negative, and this is 0, right? Like, always like no trends in charts and stuff like that. Okay, so does that make sense? Yeah. Okay, let me now think of what possibility was. Okay, so I'm writing stuff down. Okay, so let's do a color.
Transition state.
So notice that this one's a lot less math. Like it's more. There's some math in the beginning, but it's not as bad as like thermo. So that's why this quiz is like not as bad as thermo. So if you screwed up in thermo, whatever happened, did well, good for you. But if you didn't do well, like a lot of people can come back in like the second quiz. I had like a friend who she got a 10 out of 40 on the thermo quiz. She got a 15. And like the average was like 10 for my year, and like in her year. It was like really he's been making it easier. So imagine how it was for. If you guys haven't been through the midterms, like the old midterms, I had 2013, like the Katana one and like the Sheldon one. That was my midterm. So, but like she got like a 15, and then she got a C on the quiz, or no, on the midterm. And I was like, okay, if you like study and just listen to me and like just like study kinetics, like just listen to what I tell you, like it's super doable. She got a 40, like, and then like same thing for like OChem, and then like study for the final and end up with like an A- or something, right? Like yeah, so like down here to like way up here, so like you can like this quiz is super doable. Just put in the effort and you guys can do well. Okay, so okay, also one thing to note, so if I tell you this is the reaction, right? What's the rate law for this step, at least? Rates equals Ka times B, right? Now, if I tell you that's the rate, what this rate is the rate of products forming, right? That rate is rate of products forming. So this is like, technically it's like rate of C, right? That's technically it. Does that make sense? So this is rate of C, Ka-B, right? So don't like, but you can just write it as rate. Okay, a lot of people just write it as rate. Okay. Now the next question I'm going to give is we have A plus B yields C, C yields D, or sorry, and then C Hopefully I remember how to do this. T plus